Hello, students. Welcome back. We will continue with our discussion on reservoir and dam planning. So, for today, we are going to study the various zones of a reservoir. As you can see, I have already made one schematic diagram to show the various levels. But before that, I would also like to show you how there are other components of a dam which becomes a little bit necessary for at this moment for you guys to understand before we move on discussing on the various zones in a reservoir. Okay, so what I will do is I will split my screen in half and I'll use the rest part to make some diagram. So okay, so you can see here. Now what I'm going to do is I'm going to draw a three-dimensional view of a dam. Okay, as you can see, this is the cross-sectional view of a dam. So here I'm going to draw the three-dimensional view. Kindly forgive me for my drawing. Okay, so this is how it looks. Okay, if you observe this dam in the real world, this is how it's going to look. Okay, so this is here, this is the top level. Okay, and other zones are reflected. This is the ground. Okay, this is the ground, and this is what we call the downstream side of the dam, and here is the our reservoir. Okay, if that much is understood, there's also one very important component of a dam, that is what we call by spillway. Okay, what happens is when the water is up to certain maximum level, we need to get rid of this excess water. So how do we get rid of this excess water is through spillway. Okay, so spillways are constructed. Sometimes it is constructed over the dam, or sometimes it may not be on over the dam, it would be somewhere else in the periphery of the reservoir. So for now, for your understanding, let me draw a spillway that is over the dam. So people will construct the spillway something like this. Okay, so here is our spillway. So let me erase this part. Okay, so you can see, so this is a spillway and it will be something like this. Okay, there is a channel, there is a channel. So what happens is when water exceeds this maximum level, then it has to be gotten rid of, right? So this excess water is channeled from this spillway. Okay, so this is what we call by spillway. Spillway. So we are going to spill out the excess water. That is what is the spillway. And this spillway is if you just think about it, it is just a drain. Okay, a large drain, just a large drain to get rid of excess water. So here in this diagram, now you can look over here. Okay, here I have drawn this. This is what we call by the spillway. Although I am not able to give you the three-dimensional perspective, but when if it is constructed, it is constructed with some with some uh, curve in mind, so that water can smoothly flow, not like what I have drawn. It's in a curve shape. Okay, like it is shown here. Okay, so and next one is the river sluice. Now river sluice is constructed just over the dead storage. So this is the, let me say, this is the top level of the dead storage. Okay, here there is some kind of gate or a structure or a inbuilt structure, okay, inside the dam, that is connected to the outside of the, I mean, that is connected to the downstream of the dam. The main function of this river sluice, okay, river sluice is, now as you know that because you are damming the water, sediments will start to deposit. Now in this region, okay, in this region, now look here, in this region there is a high concentration of sediment which has not yet completely sedimented, but the amount of sedimentation is very high here. So the advantage would be, if we let it be here, then it will simply deposit and eventually it will fill up the dam. So to not to let that happen, what we do is we provide a sluice gate. Now here you look here, okay, in this diagram. So what happens here is this water that contains a massive sediment is flushed out. Okay, that is the main function of a sluice, river sluice, and that is just above the dead storage. Okay, the top level of a dead storage. Okay, so most important point, the spillway and the sluice. If you have understood this, now let's go and understand various storage. So I'm going to go from the bottom to top, okay, because that is easier for me to explain here. Okay, first zone, as soon as you construct your dam, then the sediments will start to deposit, and we call this as the silts, right? This silts. So it is, it's of no use. Eventually, you know, this deposition layer will increase, and just above that is the dead storage. This is the high concentration of sediments. This is not usable. This water is absolutely not usable. It contains high dense sedimentation, which is not yet sedimented, but it is in a suspension mode. Okay, so it's still in this. Eventually it will silt. Eventually it will silt. Okay, and then next comes is the maximum drawdown level. This is the maximum drawdown level. Now, maximum drawdown level means this is the level of water that you should always maintain in a reservoir. Okay, the main function, why the question why we need to maintain water at certain level is because our intake facility would be somewhere here. Intake means this water we have to take somewhere, right? We have to take it somewhere. In our case, we'll have to take it to the hydropower, right? So if it drops below this intake, then what happens is air, the atmosphere, air will get into this pipe, which is not desirable. So because of this, we always maintain our reservoir at one fixed level, which we call maximum drawdown level, below which you should not be letting your water to go. Okay, so that is one. Next level is the spillway. Now I said, right, spillway is to discharge of the excess water, so that crest is what we call by the spillway crest level. And then comes the top of the conservation storage. Top of the conservation means this is the, you know, the normal operation. On a regular or normal operation, this much water is maintained at the dam. Now, since you are constructing this reservoir or the dam, okay, the dam over the across a river, and there can be chances of flooding, right? It's expected there will be flooding. So what if there is a massive flood coming? So we also keep a little bit of space to accommodate that maximum flood. So here there is one is the top of the flood control. So this much storage is reserved for the flood control, like I have discussed last time, right? The dam reservoir is the dam is constructed for the purpose to accommodate the flood water. And then comes the maximum water level. So maximum water level is the level at which, you know, beyond which the safety of a dam can be hampered. Okay, so and this space above this space is known as the freeboard. And maximum water level, if the water has reached this level, we should open the spillway. The spillway can be gated or it can be simply an open channel. If it is a gated, then we open the gate and let the excess water pass. Okay, so this is the maximum water the dam is designed. Now if the water level exceeds, there could be so much force on this dam that this dam can topple. So because of this, this is the safety feature. So above this level, you are not supposed to keep the water. Now the storage above the normal conservation storage is what we call by surcharge. Surcharge itself means extra. Okay, it's carrying extra load. Okay, this is what we call it. The storage that is above the dead and below the top conservation level, we call it live storage. Live storage is of two types, that is it can be into two category: active and buffer. The active is maximum drawdown level to the topmost. So this is the normal operation. Whenever dam you operate a dam, the water level will be somewhere between this. Okay, so that's why we call it active, because it is actively being that is always there, right? So that is what active means. And buffer zone is the zone that is below the maximum drawdown level and the dead storage. Now one thing that we need to understand from this diagram is, although I have drawn this diagram, okay, but it is not drawn to the scale, meaning the let me explain this. Although I have shown this, right, this level is almost equal to this level, right, but in real world this is not drawn to the scale. Just to fit my scripts here, I have made it quite large, but in real world it would be just tiny, okay, compared to this active would be large, this surcharge would be just fraction of it, and likewise the dead will also fraction and sit will also fraction. The maximum portion is for active. Okay, so this is just a schematic, it's not drawn to the scale. That's why you see this kind of large gap here. This active storage and the buffer storage is almost equal. It is not that, okay. The active will always be more than other zones. This, especially this surcharge and other loads, it will be just tiny, okay, if we draw to the scale. Okay, so with this let's go ahead. Okay, so I have whatever I have explained right now, I have given you in notes, okay, so you can refer this. So there's no point of again going back to the same thing. Okay, so here it is. And before we move on, there are other things that I would like to not this one. So there are other points that I would like to you guys to read. Okay, number one is the valley storage. Number two is yield of a reservoir. Number three is safe yield. YIELD. Okay, I misspelled this. Okay, YIELD, safe yield. Number four is secondary yield. Number five is design yield. Now the term yield means the product, right? If you directly translate it, it is the product. So how much water that reservoir you can draw out, okay, you can take it out. So that is the actual meaning of this yield. So I want you to go through this term. Putting everything on a slide was not possible, so I have kept it here. Okay, so there are five additional terms which I want you to take a note of it. Okay, so let's move further. Now let's discuss about, for now let me get rid of this. Okay, so let's talk about the design capacity of a reservoir. So here how do we decide upon what is the capacity of the reservoir? How do you calculate the volume? So to do that, we have to get a help from contour map and a curve known as this elevation area curve, okay, which is also known as the elevation capacity curve. Okay, so I believe you know what contour means, right? This contour gives the elevation of a land. So here if it is 100 and this is 120, so here this is how the contours are drawn, right? So if you're constructing your dam here, and then this is the your reservoir. Now what is the volume or the capacity of this reservoir? This reservoir is not in a fixed shape like rectangular, triangle, or square. It is it's a very what do you call it? It's not a regular shape, right? It's irregular shape. So how do we calculate the volume? So we, as I said, we take the help of topographic map. So we plot the area elevation curve. Area elevation curve means, now like I have already given you the example, there's 100, there's 120, right? So now area, what is the area? Elevation is, let's say, 100. So what is the area? So you calculate this area. So let's say this area is something 50. Now next is 120. So area between this, right, this comes as a 120, right? So this is 120. So here 120 is something like let's say 70. So likewise, you plot a graph. Once you plot a graph, you get the area elevation curve. Okay, next is we use some formula to calculate the area or the volume. Now there are three ways to calculate the capacity of a reservoir. Basically it works in the same principle. Okay, it works on this area elevation curve only. The formulation is a little bit different, the formula is different, but the concept is same. So to calculate the volume between, so let me draw the two contour first. Okay, this is one contour and let's say there's another contour, right? So if you construct a dam over here and your reservoir, let's say your reservoir exactly matches the contour. Okay, just for right now I'm saying this because it becomes easier for me to explain. So let's say this is your reservoir and this is what is going to be a reservoir and this is the contour. Let's say this is 100 like previous and this one is 120. Okay, so how do we calculate the volume? Total volume is we calculate by volume is equal to h by 2. So h is the control interval. In this case 120 minus 100 is the 20, right? So that is h is 20. In this case h is 20. Okay, because that is the contour interval, times a1 is area 1, whatever the area is here, a2 is the area of the second contour, and likewise it goes on how much contours are there. So this is how this trapezoidal formula or the cone formula, prismodial formula is used. Only the formula is different, concept is same. Here also a1 means the area of enclosed within one particular contour, a2 means the area enclosed within another contour, and h is the contour interval. This is how our grandfathers used to do with the help of a contour. Now we use the GIS. I said maybe I have also given the link to in your VLE to please get started with this GIS. There are plenty of YouTube videos where you can study this QGIS, is Geographical Information System. We use this tool to do all of these calculations. Now olden days people used to use contour, area curve, that's area elevation curve, and then with the help of that they used to calculate. It was a tedious process. Now everything is digital. We do it with this software. This is the software. It's free and open source. You can download, anybody can download, it is free, and you can start learning. Okay, so with this I would like to end this lecture here. Next we will discuss about the design capacity of a reservoir. How do you decide how much capacity the reservoir has to be? How do you decide this? Calculation we have just learned how to calculate, but how to fix a capacity? Okay, this dam should hold this much volume of water. How do you decide that? So that is what we're going to discuss next. Okay guys, thank you.